Okay, so some of you are still having trouble with squiggly lines, so I'm going to go through all the homework problems from the other night. These are all nonlinear inequalities. It's an inequality. It's nonlinear because if you FOIL this, if you multiply x times x, you get x squared. Anything that's not x to the first power is going to be nonlinear. Okay, first step in squiggly line. Set equal to 0. Well, it's already set less than 0 there, so that's already done. Step 2, often the first two steps are done. Factor, already done. Step 3, find the critical points and put them on our number line. So our solutions would be x equals 3 and x equals -2 here. So I'm just going to draw a line, add -2, put a little thing, and a 3, put a little thing. Okay, step 4, plug in a big number. When I say a big number, I mean any number that's bigger than 3. We basically have this x-axis here is divided into any number that's bigger than 3, any number that's between -2 and 3, and then another interval over here would be from -infinity to -2, any number that's smaller than -2. In each of these intervals, it's either going to be all positive or all negative. And so those are the only two options, and it must touch those points. The graph must touch there. So if I plug in any number bigger than 3, let's say 10. 10 for x, 10 plus 2 is 12, that's a positive number. 10 minus 3 is 7, 12 times 7 is a positive number. Well, a positive number times a positive number is a positive y value. So I don't care where that y value is, I know it's positive. So in this interval to the right of 3, I plugged in a number. I found out the solution was positive when I plugged in 10 for x. So I know this part of the graph is positive. Now you have some choices here. First of all, at these points, you may want to kind of check and see what happens. Because this is less than, I know this is an open circle. I know this is an open circle. It does not include the points at -2 or 3. And then I need to plug in, either I have a choice now. I'll show you the old-fashioned way. If I plug in a value in between -2 and 3, like 0, what happens if I plug in 0? Positive 2 and -3. Positive times a negative is a negative. I know this must be negative. Another way to do this is to use the squiggly line multiplicity rule. What that says is this is odd. This exponent is odd, so there is no bounce. Whenever the exponent is odd, there will not be a bounce. And so there's no bounce on this one either. So it's going to go through. It's got to touch it too, -2 also. It's going to go through there because, again, these are both odd, so it's going to go through. Now, here's a positive part of the graph. Here's a negative part of the graph. There's 3 intervals here. Always look at the sign. This is what tells us what we need. This tells us that we want these values to be less than 0. That means I want the part of the graph that is in between -2 and 3. So my final solution might be written something like this. -2, 3, open parentheses, and you got it. That's the interval from -2 to 3. And that's where the graph, the y values are negative, or below 0, less than 0, just for those values. I could plug in any value there, like 0, and it would be a negative answer. It would be less than 0. And that's what we know from doing the squiggly line test. We find the interval that is the solution. This is the solution to that nonlinear inequality. Let's try another one. Okay, so this one is already pretty much factored. So I have a solution of x equals 0. And if you set that equal to 0 and solve, you get 2x plus 7 equals 0, or 2x equals -7, so x equals -7 halves. So I have 2 points. I have one at 0, and I have one at -7 halves. And this tells me that these are both closed circles. We need to plug in a value that's bigger than 0, so 1. 1 is positive, 2 plus 7 is positive, positive times positive is positive. It starts up. A lot of these graphs will start up. This is to the first power, this is to the first power. It's going to go through, come back up. This is positive, this is positive, this is negative. Where is this graph bigger than or equal to 0? Well, in this interval is all positive, so here it is, going forever in that direction. And then this part of the graph is also positive, going on forever in that direction. It also includes the points there at -7/2 and at 0. So my final answer might look something like this. -infinity, comma, -7/2, bracket, union with, bracket 0, comma, infinity. And that would be my two intervals that are solutions for this nonlinear inequality. Okay, so we need to factor this one. It's not been factored yet. So x and x, maybe 6 and 3. I think that number is negative, so the bigger number is negative. That one's positive. We get x equals -3, and we get x equals 6. Okay, so I draw my number line. 6, -3. This says less than or equal to, so those are closed circles. And then let's plug in a big number, bigger than 6, maybe 10. 10 minus 6 is positive. 10 plus 3 is positive. Those are both positive. These are both to the first power, so it's going to go through, going to come back up, going to go through. This is positive, and this is negative. This question asks us, when is this graph equal to 0 or less than or smaller than 0? Well, in this middle interval for x, all those y values are negative. And so my final answer would be the interval from -3 to 6, and those are both inclusive. They include the points at -3 and 6, and that's my answer. Here I need to set it equal to 0, so 2x squared plus x minus 1 greater than or equal to 0. Let's factor that. So I've got 2x and x, and it's got to be 1 and 1 if it factors. Hopefully it will. This adds to positive 1, so the bigger number is positive. This would have to be negative. Let's double check that. -1, 2, that seems to work. Okay, so we get x equals -1, and x equals 2x equals 1, so x equals 1/2 when you solve that. Okay, so I get 1/2 right here. So I get -1 right here. At those 2 points, this is equal to, so those are both be closed. You just have to worry about denominators. Denominators will always be open circles there. Plug in a number bigger than 1/2, like 10. That's a positive number. That's a positive number. Starts up here. That's positive in that interval. These are both to the first power. A lot of these squiggly lines look like this, don't they? This is negative. This is positive. Okay, so this one wants the part of the graph that is bigger than or equal to 0. So I want those points, because those are equal to 0. And I want points that are positive, anything bigger than that. So maybe this section here, and this section of the graph right here, something like that. And so algebraically, we might say something like -infinity, comma, -1, bracket, union with 1/2, comma, infinity. Let's see if it gets any harder here. Just subtract here, bring everything over to the left side. X squared minus 3x minus 4 less than 0, if I subtract both those. Factor that if we possibly can. Hopefully we can. X and x, 4 and 1. The bigger number is negative. Positive x equals -1, and x equals 4. So 4, -1. I've got to have this. Let's see, this is less than 0, so that's open circle, open circle. Plug in a number bigger than 4, like 10. 10 is positive, 10 minus 4 is positive. Positive times positive is positive. These are both to the first power. We've done this before. Got this. This is the negative part, this is the positive part. I want the part of this graph where it's less than 0. So I want below the line here, so that would be everything in between those two values. Algebraically, you might say it like this, from -1 to 4. If I were to plug in any value between -1 and 4, 2.5, 3, 3.9, anything like that, the values will be, that solution will be less than 0. They'll be negative, in other words. That's what we're saying. Here we go. Just solve this. You're going to multiply by x to get x out of the denominator. Those cancel. You get 4 is less than x squared. Well, let's say it equals 0. Solve it. I don't like that it's on this side, so I'm going to flip it around like that. Bring the x over, bring the 4 over, minus 4, greater than 0. Factor it. X plus 2, x minus 2, greater than 0. X equals -2, and x equals 2. So we got two parts there. Draw your line to -2. These are both open circle. Plug in a big number like 10. 10 plus 2 is positive. 10 minus 2 is positive. Starts here. Positive, negative, positive. What part of the graph do I want? I want it bigger than 0. So I want this section, this interval of the graph, and this interval over here of the graph. These two parts, these two intervals are positive. So my final solution would be -infinity, comma, -2, union with 2, comma, infinity. So the only parts that are a solution are in between 2 and -2 there. Last question, it gets a little tough. Okay, let's see what happens. I'm going to multiply everything by the lowest common denominator, so I'm going to multiply everything by x times x plus 1. You multiply that by 1, you get x times x plus 1, plus 2 times the x plus 1 cancels, so 2 times x, less or equal to 2, well, the x's cancel, so 2 times x plus 1. Okay, now there's kind of a normal equation. It's not linear, but we can solve this. X squared plus x plus 2x less or equal to 2x plus 2. The 2x's will cancel when I subtract. I go ahead and bring this 2 over, so I get x squared plus x minus 2 less or equal to 0. I'm going to try to factor that. Hopefully it will. Optimistic. Let's see, 2 and 1. Okay, this adds to be 1, so the bigger number must be positive. This one's negative. You get x equals 1, and x equals -2 for my critical points. Okay, so I draw my line. Got my point at 1, got my point at -2, and these are both closed circles, because of the sign has an equal sign there. Plug in a number bigger than 1, maybe 10, 10 minus 1, 10 plus 2 is both positive. Up here, go down here, negative. This is both to the first power, that's why we're not bouncing. And we go up, that's positive. Okay, so our solutions are, let's see. I want it when it's less than or equal to 0, so I want this part in between here and here, including those points. So my solution is from -2 to 1, bracket, bracket. That's how you do squiggly line. Again, if you're stuck on the squiggly, you don't know when to bounce. If this is 2, I would have bounced. I would have just bounced right off that point right there, just bounced up, if that was the case, or bounced down if it came from down below. So you want to just kind of check those. If you're struggling with that bounce thing, you can always go old school and plug in some value in between -2 and 1. It should be negative. Plug in any value less than -2. It should be positive. And so you can still get the same answer. It's just, if you know the bounce trick, it makes everything just a little bit quicker. So obviously I could have plugged in 3 values and I would have been just fine. It's just extra work. If you know how the bounce works, you're good to go. Hope that helped you with your homework on the squiggly line.